In this chapter, we'll talk about hydrocarbons. Hydrocarbons are compounds that contain carbons and hydrogens. They don't have any other functional group with them. It's just carbons and hydrogens. And these are four types. Alkanes, alkenes, alkynes, and we're going to add also aromatics in there with a general formula of a CnH2n. Before going into their nomenclature, let's define those two terms, saturated and unsaturated hydrocarbons. Saturated hydrocarbons, they have no double bonds or triple bonds in them. Okay. However, a cycle is okay. So you can have a cycle in there in the saturated hydrocarbon. You can have a cycle and still call it a saturated hydrocarbon in there. Unsaturated hydrocarbons, these are hydrocarbons that have a double bond or a triple bond in them. So if I have, for example, a cyclohexane, this is a cyclohexane. This is a regular cyclic alkane in there. A cycle is okay. There is no double bond in it. There is no triple bond in it. So I'm just going to call it a saturated hydrocarbon. Okay. With respect to this one is called a cyclohexene. We will discuss the nomenclature as we proceed. It is an alkene. It's a cycloalkene in there. It has one double bond in it. So the moment double bond and the triple bond is present, then I would say that this one is an unsaturated. It's an unsaturated hydrocarbon. Saturated hydrocarbon. Now, to calculate the degree of unsaturation, there is a formula to know how many double bonds or triple bonds you have in your structure. And also you can know if your structure have a cycle or not. So we said that a cycle is not an unsaturation. So you can neglect the cycle in there and call this a saturated hydrocarbon. However, when we are calculating the DBE, which is the double bond equivalence, this is what the DBE stands for. It's a double bond equivalence. We can also know if a compound contains a cycle or not. So the formula for the DBE depends on the molecular formula of the compound. And you don't have to memorize this. This is included in the cheat sheet that you are going to bring in the exam. So the DBE is the number of carbons times 2 plus 2 minus the number of hydrogens divided by 2. Normally, if the formula includes oxygen, phosphorus, or sulfur, you neglect them. If the formula includes any of the halogens, you add them to the total number of hydrogens, and if the formula includes any nitrogen in there, you subtract the number of nitrogens from the number of hydrogens to get that value in there. So you're going to end up getting a value for the DBE, and the value for the DBE is always an integer. So you cannot have it 1 point something. It is always an integer. It's either 0, 1, 2, 3, and as you go. So what does a DBE of 0 mean? A DBE of 0 means that there is no double bond or triple bond or a cycle in your structure. A DBE of 1 means that there is either one double bond or there is one cycle in the structure, because a cycle is a DBE of 1. A double bond is a DBE of 1. So you can either have a cycle or you can have a double bond in your structure. And this will help you a lot, by the way, whenever you are drawing structural isomers in there. So you would know if your structure has a double bond in there or a triple bond or a cycle. Now, if you did the DBE calculation and you get a DBE of 2, then this means that your structure contains either 2 double bonds because remember, every double bond is a DBE of 1. So if you have a DBE of 2, then you're going to end up having 2 double bonds in there, or 2 cycles. 2 cycles in there, because every cycle is a DBE of 1. So you do the combination. Or I can have 1 double bond and 1 cycle, and this is very helpful information when you are drawing the structural isomers or the constitutional isomers. Or you can have a triple bond. So a triple bond is a DBE of 2. Okay, so how will the question be? I would give you a structure and I would ask you, what is the DBE of this structure? Meaning, what is the double bond equivalence of, or what is the degrees of unsaturation of this structure in here? So what you need to do is go ahead and figure out the molecular formula for it. And to figure out the molecular formula for it, here I'm giving you benzene. All what you need to do is go ahead and add up the number of carbons, and I have 6 carbons here and I have 6 hydrogens in there, and write the formula. Always when you write the formula, carbon comes first and then hydrogens. So carbon comes first and then hydrogens, and then you go from the least electronegative to the most electronegative. So if there's a nitrogen, nitrogen comes over here, and then oxygen. Okay, so the DBE for this one, and again, you don't have to memorize the formula in there. It's the number of carbons, which is 6, times 2 plus 2 minus the number of hydrogens, which is 6 here. I don't have any halogen or nitrogen to subtract it from 6, so I'm just going to keep it like this, divided by 2 in there. And I'm going to end up having a DBE of 4. Now, you can either go with this route and calculate the DBE. That will take some time. Or you can do this. You can follow the rule that says every double bond is a DBE of 1. And every cycle is a DBE of 1. So what do I have here? I have 1, 2, 3 double bonds. And then I have a cycle in there. So this means that I do have a DBE of 4. So you know immediately that you have a DBE of 4 without plugging in and doing the calculation. Benzene is a type of an aromatic hydrocarbon. And we're going to define aromatic hydrocarbon as we proceed. But the term aromatic stands for the compound being cyclic and for the compound having alternation of double and single bonds. So you have an alternation of double and single bonds. Okay, so that is what aromatic means. When we say aromatic, we mean that the compound is cyclic, but not just any cycle. The compound needs to have an alternation of double and single bonds. So you have a double bond, single bond, double bond, single bond as you proceed. If you look here, this is not aromatic. It is cyclic, but there are no alternation of double and single bonds in there. So this is the definition of aromatic, and normally compounds that have a formula of CnHn, these are considered to be aromatic because they do have alternation of double and single bonds. Another example is here. Again, same thing. Go ahead and calculate the DBE. So you have two options. Either go ahead and figure out the molecular formula for this whole thing, that will take you time, or apply the rule that says that every double bond is a DBE of 1. So I have here 2 double bonds, 3 double bonds. So now, so far I have a DBE of 3. And a triple bond is a DBE of 2. So I have here a DBE of 5. Just add them out and the DBE is going to be